I have discovered the great ray that first brought life into the world.
The first living, breathing clone of an adult mammal.
Are we acting more like the creator than creatures? Are we trying to play the role of God and all this?
If you see it as playing God, at least we're doing good God work now as opposed to bad. And we wiped everything out.
The phrase dead as a dodo refers to something that is no longer relevant, popular, alive, or is completely gone, referring to the ill-fated dodo bird, which was hunted to extinction by the 1660s due to human actions after their arrival on the island of Mauritius. But today, the phrase itself could become obsolete with rapid scientific advancements in de-extinction technology. Colossal Biosciences, a biotechnology and genetic engineering company, has been at the forefront of de-extinction research and innovation, working to resurrect several extinct animals, including the woolly mammoth, the Tasmanian tiger, the northern white rhinoceros, the direwolf, the dodo, and the moa. Late 2024 and early 2025 saw the company's first proof of de-extinction being a possibility, with the successful birth of 3 pups built using ancient DNA extracted from fossils of direwolves, who have been considered extinct for the last 12,500 years. Professor Andrew Pask of Colossal Biosciences has revealed how this became a reality.
The method that we use is pretty much standard for all of them. So it starts off with needing that set of instructions to build your extinct species. So you've got to get that, which is their genome or their DNA. So we find fossil specimens or museum specimens of these particular animals. We're able to get DNA from that. It's something we're really, really good at now is reading that DNA, even from very, very old specimens. And then from that, you get the complete blueprint of how to build your extinct species. Once we have that, we still can't use that to bring the animal back. We can't just magically, reanimate the cells or use those museum specimens to recreate life. So we have to start still with something living. So we use that DNA blueprint to say what is alive that is the closest living relative to our extinct species. And then we compare those DNA codes. And in most cases, these relatives are something like 99% or more the same in terms of their DNA code. So then we have to edit that 1% that's different in living cells from that living animal, and then you've recreated that extinct species. And then once you've done that, we can use standard cloning technologies like we do to make Dolly the sheep and other cloned animals to turn that cell back into that extinct species. That's the basics of the nuts and bolts of it. And that doesn't matter whether we're thinking dodo or mammoth or thylacine. They're all the same.
The Tasmanian tiger, easily distinguished by his straight, unjointed tail, is also a dangerous opponent, though, like the devil, is now very rare, being forced out of its natural habitat by the march of civilization.
In Australia, the Tasmanian tiger, which went extinct in the early 20th century, has been at the front of many scientists' minds, including Professor Andrew Pask, who believes the reintroduction of the species will prove to do more than just add to Australian pride, but could be key in saving the lives of another Aussie icon.
With the thylacine in Australia, obviously very near and dear to us, human-driven extinction, we completely wiped this particular species out. But that animal played an absolutely critical role in stabilizing the ecosystem in Tasmania. So now the thylacine's gone, not only did we lose this incredibly unique species, but we know that other species there are really struggling as a result of that animal missing from the landscape. So Tasmanian devils have nearly gone extinct because they've got this terrible facial tumor disease. But when the Tasmanian tiger was around, it kept that disease in check. So it would remove the sick animals from the population and stop that disease from spreading. It's only in the absence of the thylacine that then this disease has now nearly, driven the Tasmanian devil to extinction. And that's one example of, heaps of things that are happening across Tasmania. So you really need these animals there to help stabilize all of that biodiversity and protect the species that we have left. Our closest living relative to the thylacine is a mouse-sized marsupial called the fat-tailed dunnart. So that's the one that we're engineering to bring back our thylacine, but also it's probably going to be the surrogate mum to our first thylacines, and that's because marsupials are born so small, so they're about the size of a grain of rice, right, when these guys are born. And so that means even our tiny little mouse-sized marsupial can give birth to a baby thylacine, which I think is incredible, right? And then we've just got to hand rear it with milk to raise it then up until it's an independent animal. But we actually already make all the synthetic milks for raising orphaned marsupial pouch young and things from, animals that are hit on the road and stuff like that. So I'm completely obsessed with the thylacine. But I love them all. It's just the thylacine's the one that I've been thinking about since the early 2000s in how do we actually go about doing this?
As the years progress, more and more species have been given the opportunity to have a return from beyond the grave. However, some aren't so lucky, with dinosaurs unlikely to have a grand comeback as seen in Jurassic Park.
You know what, Michael Crichton's description of how you would go about de-extinction, it's not that far off, right? We're not mixing two genomes together like they do in Jurassic Park, but we do compare two genomes and then edit, a complete copy of that original genome. But for writing it back in the 1980s, it's still amazingly accurate depiction of how you might think about doing this. Just to be clear though, no DNA left in dinosaur bones. And the whole insect amber thing, it's like the worst material for DNA preservation because it's porous. So that's even worse.
Our scientists have done things which nobody's ever done before.
Yeah, but your scientists were so preoccupied with whether or not they could, they didn't stop to think if they should.
What right do you have to invade the natural process of nature and to inject your curiosity and your ability to create new life?
Despite the successes developed in the de-extinction field, it has also raised several ethical questions by many critics, with accusations that the science is unnatural, capitalistic, and a way for those capable to play God.
Yeah, I think from an ethics point of view, we're governed by all the standard ethics that you need to do any research of this kind. So we have very rigorous ethics that we go through to do all of this work. And because it's all conservation focused is why, we're able to do this, because we are using these technologies to save species. And that's a really important part of it. But the playing God, you get that from time to time about that. But, as humans, we do this all the time. We certainly played God when we hunted each of these species to extinction. Right, so now it's the point of using this technology in a thoughtful and responsible way to bring back some of those really important species, to rebuild that resilience into these ecosystems. So I think, if you see it as playing God, at least we're doing good God work now as opposed to bad when we wiped everything out. But as humans, we've been engineering the planet since we've been around and changing the environment around us. So I think this is a very thoughtful way, and we're very careful about thinking of what unintended consequences might happen from doing this. So really studying these species in great depth, thinking about how we would thoughtfully try and rewild them back into certain areas of the planet again, how we would make sure they're having these positive benefits on these ecosystems. So there's things that we can really do to make sure we're doing this in a very responsible and thoughtful way.
Extinction projects like Colossal Biosciences have also claimed that their technology could be crucial to the next 100 years of sustaining Earth life after centuries of decay.
I think that knowing that we are also a part of that ecosystem is when those ecosystems fall apart, our world falls apart, right? It's only a matter of time. And the thing is now we know it's actually too late. We're in the middle of the sixth mass extinction. We've already reduced wildlife by over 50% in the last 50 years. It's incredible, the statistics that you can see around this, and that we absolutely have to embrace this new technology if we want to fix some of these mistakes. We just have to, and to build a healthy planet that we can thrive on as well. It's just so important. We have to, really understand the good, not be frightened about these technologies, but listen to the really good science behind it. Think about, the really good ways that we can use it, because it is our only chance at really, getting through the next 100 years. It's like the most critical period to building resilient ecosystems again, and then hopefully fixing some of the other bigger damage that we've done in the world. De-extinction science is conservation science. So these two things are not at odds with one another. It's not like, in doing this, it's preventing us from doing other conservation action. This is conservation action. Our current set of conservation tools that we've had for a very long time now are just not sufficient. So we've lost too many species that we need to replace. We've lost big populations of animals as well. So even where we've got animals left now, we've reduced down that population size to such a tiny little group that thinking that we can, just save the environment now and they will eventually repopulate that area, it's going to take hundreds of thousands of years if we naturally expect them to re-evolve back into all these different ecosystems. But using the de-extinction technology, we can actually put that genetics back into those populations. So for living animals, we can make them really healthy and robust again so they can occupy bigger areas, hopefully when we save the planet. And we can bring back some of these species that we realized too late how important they are, and they'd already gone, but now we can actually use it to reverse it. So I think it's really important new conservation tools that we can add to our conservation toolkit to make sure that we have, even more ways to conserve and preserve these incredibly important species on our planet.